right, you've given number 4 a try. So the transformations, it's going to move to the left 4 units and down 3 units. So our parent graph normally starts with an asymptote through 0. The point is going to start at 0, 1, and it's going to double because our base is 2. So 2, and then 4, and then 8. And it's going to cut in half as we go to the left. So here's our parent graph, and we're going to do 2 things to this graph. We're going to move every point to the left 4 and down 3, which means our asymptote is also going to move down 3. So I'm going to go ahead and start off by doing that just so we know where our asymptote is. So we're going to take all those points and move them to the left 4 and down 3. So this point right here is going to move over 1, 2, 3, 4, down 1, 2, 3. This point right here is going to move to the left 1, 2, 3, 4, and down 1, 2, 3. And then this point to the left 1, 2, 3, 4, down 1, 2, 3. And then right here we're going to take this point and move it to the left 1, 2, 3, 4, 1, 2, 3. And as you can see, those points, if we connect them, we're going to get that same little exponential curve, but everything's been shifted to the left 4 and down 3. So here's the thing, ladies and gentlemen. As long as you can name those transformations, I'm okay if you get your points off the graphing calculator. So if you can look at that and tell me that moves to the left 4 and down 3, then what you can do is go to your graphing calculator, go to y equals, and you can type in that equation. So you can type in 2, and then in parentheses put x plus 4, and then minus, oops, you got to make sure that minus is down there, minus 3. So then what we can do is go to our graph, and that looks like what we just graphed. But if you want to double check, you can go to the table and see the points there. So the point -4, -2. It looks like we graphed -4, -2, -3, -1, -2, 1. So as long as you can correctly say left 4, down 3, I don't mind if you don't draw your parent graph anymore and your new graph as long as you can say these things. So our domain's going to be all real numbers, and our range is going to be -3 to infinity. So let's try number 6. There's a couple different things. We've got this minus out in front. That tells us we're going to reflect over the x-axis. And then we've got that -2 up there, which means we're going to move to the right 2. So as I was saying earlier, as long as you can make those statements, I don't care if you draw your parent graph anymore, we can go straight to our graphing calculator and grab some points. So let's do it. We're going to hit -2 and then raise that to the x minus 2 power. So then when we do that, we can take a look at our table and grab some points. So there's some tiny stuff. Let's wait till we get some numbers. There we go. Okay, so we can plot the point 2, -1. We can plot the point 3, -2. We can plot the point 4, -4. We can plot the point, hold on, I messed up somewhere. 3, -2 is right here, so ignore that guy. And we can plot the point 5, -8. The one thing I want you to take note of is whether something moves up or down. Because if something moves up and down, that asymptote's going to move with it. Just like here we had up 3, that asymptote moved up 3 units. Here we had -3, that asymptote moved down 3 units. So here, is there anything out here having us move up or down? Nope, there's not. So we're still going to have an asymptote at 0. So when we connect these dots, we're going to connect them, and it's going to approach 0, this time from the other side, but it's still going to approach 0. It's never going to touch it. So when we connect these points, we're going to get this. So the domain is all real numbers. You've probably noticed a pattern that it's always going to be all real numbers. But this one's different because it's going down forever instead of up forever. So the range is going to be -infinity to 0. All right, go ahead and flip over to the next page, and we're going to take a look at solving these guys. So here's what we need to look at. If we have a base of b to the x power and a base of b to the n power, then we can say if they equal each other, if the bases b are equal to each other, then the exponents must equal each other also. So we can say x equals n. But the key here is that bases must match. So looking at these problems, not all the bases match here. Here we have a base of 5 and a base of 125. But here's the thing. We can rewrite these by thinking of our special powers. So take a look over here. Let's jog our memories a little bit and remember some of our special powers. So 2 to the second power is 4. So if you ever see a 4, you can write it with a base of 2 instead. 3 to the second power is 9, so if you ever see the number 9, you can write it with a base of 3 instead. 2 to the third power, 2 times 2 times 2 is 8. 3 to the third power is 27. 3 to the fourth power, 81. 2 to the fourth power, 16. 2 to the fifth power, 32. 5 squared is 25. 2 to the sixth power is 64. 5 cubed is 125. How do we get fractions? Well, we get fractions by raising something to a negative power. So if we want 3 on the bottom, we do 3 to the negative 1. If we want 9 on the bottom, 9 is 3 squared, and to get it underneath, we do 3 to the negative 2. How do we get radicals? Well, we do that by raising it to a fraction. So there's an imaginary 2 here in an index. If you don't see something in a radical, assume it's a 2. So this is a to the 1/2, and this is a to the 1/3. So these things are important to know because they're going to help us get like bases. So here we've got 5 to the x power. And over here we have 125. But is there a way that we can write these with the same base? Yep, we can write these both with a base of 5. So we've got 5 to the x power, and then how can we write 125 as 5 to the something power? Well, if we look over at our chart, 5 to the third power is 125. So we can go back over here and write this as 5 to the third power. It's the exact same thing, but now that our bases match, these 5s match, then we can say our exponents must be equal. If these are equal, then the exponents must be equal. So we can say x equals 3, and look at that, we are done. So let's take a look at number 2. 8 and 4. If we look over at our chart, we have 4 and 8, and they're both written with a base of 2. So we can rewrite these with a base of 2. So let's do it. We can write 8 as a base of 2. So 2 to the third power, and we've still got to raise that 8 to the x power. So we're going to write it like this. And then over here, we're going to have 2 squared to the x plus 1 power. Okay, so we're still not completely done because we've got powers to a power here. What do we do when we raise a power to a power? Well, we multiply. We're going to do the 3 times the x, and here we're going to take that 2 and distribute it to both the x and the 1. So we're going to have 2 to the 3x power equals 2 to the 2x plus 2 power, because we took that 2 times x to get 2x, and that 2 times 1 to get 2. So now we're happy because we have the same bases 2 and 2, so we can set the exponents equal. 3x equals 2x plus 2. So we want to get our variables on one side and our constant on the other. Since our constant's already alone, let's get this 2x to the other side. We can do that by subtracting 2x from both sides. So x equals 2. And look at that. We're done. We solved for x. All right. Number 3 is a little bit harder because we've got a fraction here, but we can handle fractions. If we see 2 and 8, what base comes to mind? A base of 2 should come to mind. So this is already written with a base of 2, so we can just keep 2 to the x plus 5 power. But now 1/8, how do we write that? Well, let's look over here. Do you see 1/8 in your chart? No, but we do see 1/9. We know to get 8, we can do 2 to the third power. And we know to get a fraction, we can do a negative. So if we do 2 to the negative third power, what that will do is make it a fraction. The negative will make it a fraction, and the 2 to the third will give us the 8. So we can write here 2 to the negative third power. That's the same thing as 1/8. So now we can take those exponents, set them equal to each other, and we can do that because these both have a base of 2. So we can say x plus 5 equals negative 3, subtract 5 from both sides, x equals negative 8, and we're done. All right, so at this point, if you're feeling pretty confident, I would suggest giving the rest of these a try. But if not, you can keep watching the video here. I'm going to go through every single one of these. Either way, when you're done, check your work and make sure you're feeling good about all of these. And then I'll be back tomorrow to review this with you. Just a reminder, when you're finished, your homework is on the next page, page 12. So I'm going to pause the video and then pick it back up and go over all of these with you.